Welcome to the part 2 of this tutorial. In this video we will work with the movement. So select a player and let's create a new script. Call it character movement manager. And let's open it. So let's start by creating some variables. Let's create a private float default speed, let's say 6. Let's create a private float walk speed 1.5, private float jump speed, and a private float gravity. Let's organize this a bit. Let's create a header here. Let's call it character movement. And let's make this serializable. If you don't know what serializable does, it just makes the private variable visible on the inspector. And the header is like a tooltip. Not a tooltip, but I'll show you. So if you select the player, you can see here character movement and it's misspelled. Let me fix that. Okay, let's create some more variables. Let's add another header. Let's call cart attributes. Let's add a private float character height equals 2, and a private float character height crouching. Let's say 1.5. We'll also need a character controller. Private vector tree move direction vector tree dot 0, private float speed, private pool is walking, starts false, private pool is crouching, also false. And we just need two more, private float mouse X and private float mouse Y. I believe we have all the variables we need. So now let's create our functions. Let's start with the start function. Let's start by assigning the character controller is equal get component character controller, speed is equal to the default speed, and character controller dot height equals character height. Okay, so we have everything initialized here. let's go to the update function. Okay, first we need to get the mouse input. So let's get mouse input and let's create that function. Private get mouse input forgot the void here. This one is very simple, you just need to do mouse x equals input.get axis horizontal. You can copy it to y and here change to vertical. Now let's do another function. Let's check if he's crouching. Let's create another function here. Private void check crouch. Here we will just check if we are not pressing the control key. So if input dot get key app key code left control character controller dot height equals character height and is crouching equals false. So this is basically to check if you are not pressing control or will release the control key, our height will be the normal height. We'll be no longer crouching. Let's go back to the update function and let's do an if character controller dot is grounded. Let's call another function grounded, sorry, movement, else not grounded movement. So if our character is grounded, we call this one. If he's like in midair or jumping, we call this one, because we don't want to walk midair or crouch midair. So let's create those. Let's start with the ground movement. Private void ground movement. So let's start here. Let's check if you are pressing control. So if input dot get key code left control, and here we can just copy. Where is it? Here. You can copy this, but instead of the character height, here it's character height crouching, because we are crouching, we are pressing control, and crouching is true. We can comment here like crouch. Now let's check if we are pressing shift to walk. We do the same. If input dot get key code dot left shift is walking equals true, else is walking equals false. Now we need to check if the player is crouching or walking. We need to decrease its speed. So let's check that. So if is walking or is crouching. So if you're pressing control or shift, the speed equals walk speed. Otherwise, speed equals default speed. Let me check everything. Oh, my bad. Sorry. My mistake. We don't need the mouse input. It's not the mouse. Let's rename it get input. And here let's call it horizontal movement. And here vertical movement. This is the input from the keyboard, like left key, right key, front key, arrow key, or WAST. Let's rename it. No, everything is fine, right? Yeah. Let's just rename up here. Horizontal movement, vertical movement. Yeah, that's fine now. So let's keep going. So we check if we're crouching, then we check if we're walking. If either one is true, our speed changes. Otherwise, it's the default speed. Now we need to start creating the vector to move our player. So move direction is equal to transform.right times horizontal movement plus transform.forward times mouse, again I'm writing mouse, vertical movement. So transform right times horizontal movement plus transform forward. Yeah, that's fine. Now let's normalize this, because if you don't normalize this, if you press both front and right key, you move faster. So if you move diagonally, you'll be moving faster because you're adding two vectors and it moves faster. By normalizing, it means that if you're moving diagonally or not, the speed is constant. We can do that simply by doing if move direction dot magnitude is bigger than 1. Our move direction equals move direction dot normalized. If you only write this line like this without the if you are using a joystick or something like that, it will not work as smoothly. You need to check if it's bigger than 1. And finally, we need to multiply the move direction for our speed. And for the ground movement, that's basically it. So while crouch, we got our movement vector. We need the jump. So if input dot get button jump move direction dot y equals jump speed. Alright, so we just need the not ground movement. That means we are mid-air or jumping. So void you don't need to write private. If you don't write anything, it's the same, but it's easier to see it's private if you write it. That's just a personal preference. You don't need to do much here, you just need to do if is walking or is crouching, the speed equals walk speed, else the speed equals default speed. And let's create a vector to move. Move direction equals transform dot right times horizontal movement times speed plus new vector tree 0 move direction dot y less gravity times time dot delta time 0. Let's break it here so we can actually see everything. So transform right times horizontal movement speed vector 3, okay, and plus transform dot forward times vertical movement times speed. I think it's done. Let me check. Not grounded. Okay, we need the final thing that moves the character. So character controller dot move direction. It's our vector times time dot delta time. If you save it and you go back to Unity, it should work. Let's give it a shot. You can look around. It's hard to see if you are moving forward. Let me do something here. Let me create an object. Let's create a cube here. Duplicate it here. Another one here. Let's do that again. You can see we are actually moving. We can jump. We can crouch. And we can walk. This is how we can create a basic FPS script for movement and camera. You can change the values as you like. You have them here on the inspector. Let's just clean a little bit the script. Let's go back to it. So here we can add a tooltip. Character default movement speed. Right, so here character walking speed, character jump, let's say jump force. Here it's a gravity, so gravity force on character. If you want to know, like the real world gravity is if I'm not wrong, 9.81, but it's not realistic. 20 gives us a better feeling, in my opinion. We can make this one also serializable. And here it's character default height. And this one is crouching height. If you now save it, let it load. Yeah, here we have everything now. Default height, character height while crouching, default speed, walk speed, jump speed. You can change this as you like. And if you leave the mouse, you can get a description of what it does. So let's change the speed to 10 and jump speed like to, let's go 16, double. To play again, you can see it updates. And that's it for the tutorial. If you want me to do more FPS scripts, let me know, but right now I'm more focused on the beginner's tutorial series that I'm doing. But if you really want this, just let me know, I can try to create more scripts. And that's all. If you like this type of stuff, feel free to subscribe, and I'll see you on the next video.